All right, hello everybody. This is Mr. Kimpton, and I'm going to talk to you about the life cycle of stars. There's a famous quote by Albert Einstein that says, "Watch the stars, and from them learn." Pretty much everything in our universe at some point in time has been made by stars. So, what is a star? A self-luminous body of hot plasma that generates energy by means of nuclear fusion reactions, much like what we talked about with our sun. It must balance its internal pressure against gravity. If this cannot happen, the star dies. So stars exist for billions of years. Our sun is a medium-sized main sequence star. Most stars are much larger than our sun. Stars can follow different life cycles, which we'll talk about in just a little bit. Stars are classified by 7 characteristics: their size, mass, brightness, color, temperature, spectrum, and age. All stars begin as a ball of gas and dust. So gravity pulls the gas and dust together into a sphere, and as that sphere becomes more dense, it gets hotter, and the hydrogen changes to helium. So that nuclear fusion that we talked about with our sun is totally what keeps a star burning bright. But burning probably isn't the best term to use. As stars age, they lose some of their material, usually slow, but sometimes very fast, in wicked big explosions, which we'll talk about in another video. Stars can take many paths in life. However, in the end, much of their material returns to space, literally dust to dust, if you've ever heard that phrase before. Some of the material combines with more gas and dust to form new stars, and that cycle can start over again. So there's different types of stars, and they're classified by 7 characteristics: size, mass, brightness, color, temperature, spectrum, and age. So those things that we use to describe them are the same things we use to organize them or classify them. So the main sequence stars, there's quite a few of those, and those are like our sun. There's giants and supergiants. Then there's things called white dwarfs and red dwarfs. You'll see all of these on a chart later on in another video. So why do we have all these different stars? Well, it's because of all those different ways that we compare and contrast them. They all have different characteristics. Primarily, the different stars are because they are in different parts of a star cycle, their life cycle, and depending on what they're made out of, and how big they are, and how long they've been around for, they could be taking a different path through life. So a lot of things start out as a stellar nursery, as you can see here on this part of the diagram. And usually this is from a nebula, collapsing clouds, interstellar gas. So all of this unorganized material that then, because of gravitational pull, forms into a star. So we have sun-like stars. This is a pretty common path that then inflate and become bigger to a red giant. That's what will happen to our sun. Fortunately, not in any of our lifetimes. Turns into a planetary nebula. Feel free to research some of those more on your own. Then a white dwarf to a black dwarf. All right, more massive stars, huge stars, usually very large blue stars, they'll inflate to what's called a red supergiant, right? Because they have more mass, they have this ability to have more nuclear fusion and burn higher, more complex elements. Those will go to what's called supernova. Okay, giant stars down below, 3 times the mass of the sun, they will also inflate the red giant star, go through supernova. But when they're going supernova, supermassive stars go into what's called a neutron star, and we'll talk about these a little bit more later. And the very, very most massive stars actually turn into what everybody's really interested in, which are called black holes. So when stars get old, stars have 4 options at the end of their life. We just talked about 2 of them, which will come up again, depending on where they are in their life cycle. Average stars like our sun, like I said, those usually turn into some type of white or black dwarf. Stars that are more massive than the sun die in those intense explosive phenomena. And we'll probably spend a little bit more time talking about those. So intense star death would include supernovas. Most of them go through supernova and then go through neutron star or a pulsar and or become a black hole. So Supernovas are a gigantic explosion in which a massive star collapses and throws itself into its outer layers into space. Neutron stars are really cool. They're a star that has collapsed under gravity to the points that the electrons and the protons have smashed together to form neutrons. So they're actually creating different types of subatomic particles, um, and they're very closely related. They don't necessarily look like this in outer space. However, this would be a graphic representation of what they would look like. Pulsars are rapidly spinning neutron stars. So they're really kind of the same thing, but once you get it to spin, it's going to create this pulse of radiation, which can be picked up in the form of radio waves. Um, so we know these things are out there because of the frequency of radio waves that are coming from deep, 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 deep space. And what everybody's most interested in are the black holes. There's lots of research being done about these, but they are created by an object that is so massive and dense that even light cannot escape its gravitational pull. Um, it is thought right now that we have a monster black hole at the center of our galaxy called the Milky Way, and it's quite possible that all galaxies have a black hole at the center of them. So if you get a chance, there's a great Nova special, and it's called Monster of the Milky Way, and we'll probably watch this at some point in class or during academic seminar. All right, so that's star life, cycle, and death. Check it out. I would go look at these more in your book, and there's tons of great information out there about all of this. Have a good one.